Okay, so this one, if 250 milligrams of radioactive element decays to 240 in 36 hours from half-life. So half-life, remember, is part of this formula, R equals ln of 0.5 over half-life. Okay, so that is obviously two variables in that little equation, so we've got a problem there. We can't really do that. But let's kind of work over here. Let's say if 250 is going to go down to 240, E, now R I don't know, but T I do know now. It's going to take this to be 36 hours. So now I'll have 250, divide both sides by 250, so I'll get just 20, I should write it's 24 or 25 here, is equal to E to 36R. Hopefully you can see right now where I'm going to go with this. 24 over 25 is equal to L on both sides of this. So L on this side would be 36R. So then R is going to equal this. Well, why did I do that? Remember what we said, this is the half-life. This is how I can determine half-life. And now you can do one of two things here. If you want to put, if you want to go a little bit further with that formula here and just solve this for half-life, you can. I'm just going to do it a little bit more direct. I think I'm going to, R is ln of 25, that's 24, sorry, 24 over 25. Divided by 36 is now equal to, R is equal to this thing. It's ln of a half divided by my half-life. I'm just going to use half-life as capital H. Now out of proportion, I can cross-multiply. So I'm going to cross-multiply, do this in blue. We got H ln of 24 25ths equal to 36 ln of a half. So then capital H, if I isolate that, would be 36 ln of a half divided by ln of 20, keep doing that, 24 25ths. So it's almost like a system of equations of trying to solve for the half-life here. So we got 36 ln of 1/2 divided by ln of 24 25ths. It gives me 611.27, which is exactly what we're looking for there. And then I'll get down here. I think one of these last ones are dealing with sigma notation. That's throwing some people off. Yep, that's it right there. I'll show you a couple things here, just kind of explaining the concept again. We've said that obviously if I start with, and all our rules were I starting at 1 and going to some n value, where maybe that is, let's just do one that we go to 6, okay? Well, if it's of I, remember all that is saying that, okay, if I is equal to 1 here, plus I is 2, I would be 3, 4, 5, and then 6. 3, 4, 5, 6. So obviously just plugging in I being 1, that would be 1. Plugging it when I is 2, it would be 2, 3, 4, 5, 6. So what we're looking at there is just the sum of the first 6 integers, or first 6 natural numbers, I guess. Okay, so how do I do this if my goal is to just find maybe from I equaling 4 to 6 of just I? Well, that means the 4th term, so that's when I is 4 plus then when I is 5 plus then when I is 6. So that'd be 4 plus 5 plus 6. And that's fine, you can do that, okay, but this one's going to be a lot nastier, okay? So the idea is that this thing here, okay, can be found by taking that black one I equaling 1 to 6 of I. So that gives me this black phrase of 1 plus 2 plus 3 plus 4 plus 5 plus 6. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 would give me that. Now if I remove from that I starting at 1, but going to 3 of I, that would be minus 1 plus 2 plus 3. If I do that, so it's minus a quantity, you see that this negative 1 here is going to cancel with that one. This negative 2 is going to cancel with that one. And this negative 3 is going to cancel with that one. It leaves me just 4 plus 5 plus 6, which is exactly what I wanted here. So we see then I equals 4 to 6 of I, that we can do kind of a manipulation like that. Okay? Basically, I go from I to 6. I from 1 to 6, the entire list. And then I remove from it the first however many terms that are not included in this one. So if that was a 5, okay, so if this was 5 to 6, this number would be a 4. And so we'll kind of manipulate that and work through that here on this one. All right, so let's clean all of that out. This one here, a couple things going on. The first thing I think we'll address what I just talked about. I don't want to, I can sit down and I can say, okay, well, that is going to be, J is 9, so I'll go 9 squared, 1 plus 9, so that's when J was 9. Plus then, when J is 10, I'd have 10 squared times 1 plus 10. And then when J is 11, I go 11 squared, 1 plus 11. You could do that. I think that's going to be a pain in the butt. You can kind of see a pattern, though, that it's going to be, it's 9 squared times 10, plus then 10 squared plus 11, plus it'll be 11 squared plus 12, and then plus 12 squared plus times 13. You can kind of see a pattern there, and maybe that help you write it out a little bit faster, but it's still going to be a pain in the butt. And what happens if I change that to 190? You're still writing that down, and I'm done with the assignment. So how do we address this? Well, I think the best thing to do is this idea. If I want to say J equals 9 to 19 of whatever, that's going to be the same thing as the sum J equals 1 to 19 of that whatever, minus then, so this is the 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th terms. So I do not have in there the terms 1 through 8. So let's subtract those out of this list because that's including 1 through 8. So let's go J to 1 to 8 of whatever. If I can do that, if I can subtract those two things, that's going to equate to this. So I've got the kind of the setup. Now, that is a pain in the butt. I don't like J squared. Okay, times 1 plus J. I'm going to do this. I'm going to rewrite this as, I'm just going to distribute the J squared. So it gives me J squared plus J cubed. What we talked about with our property is that is the sum of J squared plus the sum of J cubed. Okay. Now from, again, 1, this would be J from 1 to 19, and this would be J cubed, J to 1, from 1 to 19. Let's evaluate those, okay? Well, we could, let's see if I still got that list here. Yep, still got these here. So we can say that anything squared, I squared, J squared, whatever variable you're using, is n plus 1, 2n plus 1 over 6. Okay, so n in this case would be this 19. So I would say this thing here, instead of writing out 1 squared plus 2 squared plus 3 squared plus 4 squared all to 19, I'm going to write n plus 1, 2n plus 1, so this would be 38 plus 1 would be 39, all over 6. Okay, so that is, again, bringing up that rule, n plus 1, 2n plus 1. If I look at I cubed, it's n squared, n plus 1 squared over 4. n squared. Okay, so it'd be 19 squared, n plus 1, which will be 20, all over 4. So that is going to be essentially what goes in. I'm just going to put a red star right there. I'll do everything else in maybe green here. But that's going to be what is that quantity right there. Well, we need to remove from it the first 8 terms. So let's find the first 8 terms. So really what it is, it's still exactly this thing here, but instead of 1 to 19, it's 1 to 8. So then again, we do the same thing. J squared is n plus 1, 2n plus 1, all over 6. J cubed, okay, is n squared times n plus 1, all over 4. That's what would go right there. So let's use Desmos here to kind of type in all this garbage. And I erased some stuff, kind of haphazardly, so let's see if I can go from memory here. So this object that goes here would be, that would have been 19 times 19 plus 1, 20, and then 2n plus 1, so it'd be 30, so it's a 39. And then we put that all over 6. And then we're going to add to that. Okay, so it was n squared, so it would have been 19 squared times then n plus 1, so it'd be 20. All of that. Oh, so this is a nice thing about Desmos. I put the parenthesis in the wrong spot, so it was showing me that I had the parenthesis in the wrong spot. Unbelievable. There we go. Whew. Divide that by 4. Okay, so that there would have been j equaling 1 to 19. I want to then subtract from that what I've got written there in green. So that would be a little bit easier to type. 8, 9, 17, so that stuff is all over 6. But then I'd have plus, and it becomes, let's do 64 times 9 over 4. It gives me that number there. So I'm looking at 3927. Is that what we were looking at? No. So let's see here. What did I do wrong? I got parentheses in the wrong spot, something like that. J squared plus j cubed. I went from 1 to 19. Let's see. So let me just rewrite that 1 to 19 real quick. So j squared is going to be, so it's n plus 1, 2n plus 1, all over 6. So let's make sure I had that typed in right. So 19 times 20 times 39 divided by 6, plus then j cubed. So j cubed, double checking, cubed is n, there's, I forgot the squared, n plus 1 squared, that's the problem. So make sure you're copying those rules down. So right here, that's squared. And the same thing. All right, I got it. So this would have been, this is 20 squared, so that's 400. And then this one over here, that's 9 squared. There, we're getting the 37,070 that we're looking for. Okay, so that's just my fault on the missing that exponent. But the procedure obviously is the same. So just be careful with that. Now, there are some nice kind of tools that you can use. If I go functions here, go to miscellaneous, go to that, you're going to find out that if I go from, is that what we wanted? When we go from 8 or when we go from 9? We go from 9 to 17. So we're going to go using n. So n to n squared plus 1. Is that what we had? No, I messed it up again. So it's n squared here. N squared. This is n plus 1. Have a good weekend. Thank you. Absolutely. Not going to 17, we're going to 19. So just make sure you type everything in correctly. But there you see that's giving me that thing there. The TI-8384 has the same tool. Okay, now it's kind of hidden. If I want to I go to math. I'm going to go all the way down to summation. Type in summation, you see that gives me that. So just use a variable, doesn't matter which one. 9 to then we see 19. And then if I type in, just because it's easier this way, x cubed plus x. I always do that. X cubed plus x squared. We get the value that way. If you don't have, I'm not going to do too much with this, but if I don't have math print on my calculator, so I got one of those old TI-8384s, and I hit summation, it's just going to give you that. And I think, let's see if I can do this. And some of them might just say sum. So even the fact that's giving me that symbol there is more than what some of your TI-8384s will do. So let's just put in, let's see if we go x squared plus x cubed. I think I have to tell it the variable I want, x. I think I need to tell it the starting point and then the finishing point. See if that gives me the same thing. There you go. So again, so it's the expression. It's the variable that you're wanting to be plugged in. That's the lower bound, n equals 9 in this case, and then the 19 be the upper bound. So that's how you can do that with that calculator. Like I said, though, on the TI-83 or 84s that are just kind of the grayscale, if I go to math, go all the way to the bottom, oh, I don't even see it there. It doesn't even have that tool. Wonder if I can go catalog and find it. If I can catalog, go to S. There's some, so it's somewhere. I just don't know where it's located. Let's see if it will go x squared plus x cubed, comma, x, comma, 9 to 19. Doesn't know what my argument is. I don't know what. It might, this calculator might just sum. This might just be I might just be able to put a list in and that's it. Where I go 2, 3, 4. See if it sums those. No, I'd have to search what the what this function is actually doing on TIA 384. So I guess there is a benefit to having the newer calculators. If we have this operating system, we'll see what happens there. If I go to math, there it does have the summation one. It allows me to plug it in that way. If I go to Classic, let's see what it looks like in Classic. All right. So those newer calculators are going to have a little bit of benefit to them. You can do the same thing with GeoGebra if you're a person that likes that. Now, the reason I like GeoGebra, if I type in sum, it gives me some options here. And down here is the one I want: expression, variable, start value, end value. Now once I hit parentheses, I got to remember what that was. So, so what do we have? J. So we have J squared plus J cubed, variable J, started at 9, finished at 19. There's that number. So those are options for you to kind of manipulate those summations. So everybody's always asking, like, well, if I can do that with my calculator, why do you even teach us? Why do we even go through this? There might be a situation. So you're going to use these in calculus. You start talking about things called Riemann sums. You'll do this in calculus. You don't know who your calculus teacher is going to be. Okay, you go to college. Some programs will say you can't use a calculator. Some programs say, when I took algebra or started college, calculus 1, I was not allowed to use calculator. So that became an issue. If I've always relied, in some instance, on my calculator to do something for me, when it got taken away, I ended up in a precarious situation, and I had to go teach myself that algebra so that I can address it within the calculus. So this is something to think about as you guys progress forward. Again, though, if you are using calculator and there's anything you ever question, like, can I do this on there, let me know. Maybe I can explain it during class or through a video like this, and maybe help out in that fashion. But my hopes are, again, that you're using them in a correct manner. My hopes are that you're going through this by hand, using the procedures that we went through that I showed you, and then using your technology to verify that what you have already done is correct. I think if you use it that way, then that's a tool that's going to benefit you and not hamper you.